previous slides, is about architectural glasses and about electronic glasses. We found two companies with very good profiles. For example, Monocrystal produces silicon on sapphire crystals for solar glasses, and covering glasses are very strong. And it's a partner of Apple. They have a contract for about $27 million for glasses Apple Watch. And this one, Glaser, is very interesting for us company because it has production of glasses, advanced glasses, for about this volume, 12 months. And the technology that they used is almost the same. That's why we found that's why we found that it's not an interesting option for us. And the next speaker is as for technology, in general, we use technology is widespread. Your plasma protein, and also for Russia there is small window in market government state order for space agency where we can use our technology and have a contract. But we try to present some technology universe, and our constituent technology consists of such parts. So we look into related technology and competitive technology. But we can follow Steve Jobs' experience and use technology. We can combine, we can use our competitive advantages and combine some human resources to, we can develop any specific coating on any, for any specific customer's demand. And as for future, we think that it will be interesting to source maybe solar windows for Russia with extreme environmental conditions. It will be very prospective and energy saving. Uncertainties in our universe. And we see two options. We can focus on domestic market to substitute the production and import of foreign expensive glasses. And we can develop technologies according to the global market requirements and standard needs in order to enter later the global market with our technology in such a way. Thank you very much.
Thank you.
But do you put coatings on glass, or do you make the glass itself, or just do coatings on glass?
Our technology is to make coating for glasses.
So you buy the substrate glass.
Any kind of covering glass of glasses.
Okay.
Any kind.
So you don't do, you know, in solar, there's these glasses that are cerium oxide coated glasses. Do you know these? They're covered glasses so that in space, as they get irradiated, they don't cloud up, so they stay clear. You know, they're the, like radiation hardened glass.
Oh, duration of glasses.
Yeah, do you know those? Like do you have this cerium? Do you know cerium doped glass? Have you heard about this at all?
Doped glasses?
Yeah.
Yeah, so specifically cerium doped glasses. Like the chemical symbol is C. Do you know that?
They're used in.
No, but doped, right? Not
Yeah,
coated,
they're
doped,
doped.
right?
Yeah, so it's the
So it's
glass
inside the
themselves.
glass.
Yeah.
We can use magnetron not only involve energy sputtering.
Okay, so you do implantation.
Yeah, we
Okay.
can do implantation, and this technology is used for this.
Okay.
Yeah, because you know, in the international market, there's like this one company in England that sells these cerium doped glasses for some ridiculous price, right? Now the market is like, it's not super big, but it's very, very profitable for them. And just because of your space thing, I thought, you know, if you want to sell it to the international market, that's just one area that, you know, but that's me doing innovation process.
Yeah.
on this, you know.
So
Yeah, so I should do the innovation process.
yeah. So in terms of structuring, you see, so your technology, so you have a magnetron, and you can obviously change your coding, change your energy, and so on and so forth. Okay. And a lot of other research institutions, have the same thing, have the same setup, right? So the question, is sort of like, as far as I'm understanding, you basically are at the research stage, right? You have a research lab, you have experimented with all sorts of coatings, right?
Yes.
You have measured their
We
properties.
already have one contract with space agency. And
Right.
For we make a special coating on glass for illuminators.
Illuminators.
For specific windows.
Oh, for Windows. Okay, Windows. Okay, yeah. Okay, so, but beyond that, okay. So that's like a small scale, right? Yeah. So okay.
Our organization are research organization,
Just-
so
yeah.
we can't.
Sure.
Sure.
Yeah, but in the innovation process, if we were to go forward and actually, over time do this, then we might get an idea, and then eventually you can get more resources. Or
Yeah.
whatever,
So basically, but for the other classes, basically what you've done, in your research, right, is you've tried all sorts of different coatings or implantations, okay, and you measure their properties, right, with respect to what you showed in the beginning, heat, abrasion, scratch resistance, and reflective, and so on, okay. So the question is, okay, well, how do you use that knowledge, right, to create new glasses, right? So in your technology universe, because you've done all these different experiments, that's relatively easy to fill out of everything that you basically can do. I mean, that's you sort of put everything there, not but the real thing that needs to come in, more than just listing the customers or the large markets, is the actual sort of needs, right? And that's what, so you started, you did well in terms of starting your research in the competitive space, but you're still on very high level. You go like, okay, well, we kind of know what these companies are, and in general, that's a good starting point, okay? But you really kind of need to know, like, okay, what is the product that they're doing, right? What kind of market need are they satisfying? What are the specifcations? Like, for example, yeah.
Yeah, that's the next step you're going to.
So because you have to.
To apply our technology to this niche and to
Right.
find very specific segment of our market.
Yeah, but you have to find.
Yeah.
Yeah, exactly. You have to find a need. You have to find a need that current companies are not satisfied, right? So the restriction in Russia of the import zone, okay, that's really sort of like an addition. It shouldn't be the starting point. Okay,
You know,
it should be like you need to make the universe as if this doesn't exist. That restriction goes into implementation. Right? It's not actually like a primary market criterion, right? The market, because the people, like what they need, okay? It should be like that. It doesn't really, that's really the need and the desires, right? The legislation around it, same things, even like, I don't know, import tariffs or, or any kind of like legal regulation, that's regulations, okay? That's an implementation, right?
You were going to say something?
I guess that our specific niche maybe they are called
Yeah, you were going to...
нам сейчас сказал. Точно. Мне кажется, вы начинаете
Our special product can be for high-rise building. On the top of our city should be built very high building, and such solar window can be used for them because it saves some energy, and I know people who can account this economy for us, and we can promote such special product with our covering for such building companies.
But the thing is, like, in terms of solar windows, yeah, something else. But this is one of those specific things, that happens in research a lot, right? Is like a lot of people have been trying this solar window thing, okay, right? A lot of research institutions. There were a lot of like.
So when you say solar window, you mean a window that generates electricity? Is that what you mean?
It will be covering for windows, for glasses.
But it generates electricity. Is that the idea?
Yes, it's a
Yes. So what's interesting about that? There's a technical detail you should look. So part of the innovation process is you have that potential market, right? Then you have to look at the
We
detail.
always have this potential market here.
Right. So then you should look at now the details of the technology behind that, right? And then look at the implementation for that, right? And what you'll see is you should do that because you need to capture that in your minds, right? One of the things you'll see about that solar window application is that there's actually competing criteria, right? Because in a window, you want light to go through, right? But of course, in photovoltaics, the most efficient cells are the ones that capture all of the light, right? So you need to think about those details, which is that go through in your mind and say, what are the criteria? What would this building like? And what you'll find out probably is that, you should go through that process, but you'll find out that the performance and the cost is very difficult, but you should look at that.
Yeah. So you have to really make it, so for this example, all right, just to sort of illustrate it, but there's many other things, like the universe, we're talking about, should really be a lot bigger, okay? But so in this case, right, what you would need to do, right, is you have to say, okay, right, let's suppose, okay, you don't have to do any experiments here, okay, right? Let's suppose I can make any material I want, right? So I take the solar spectrum, right? I say, okay, fine, I don't want tinted glass, right? Okay, I want to be able to see through it in the building, right? So I have to take out the visible spectrum. Because the visible spectrum has to go through, right? The only thing you can work with for energy, okay, is ultraviolet or infrared, right? That's the only thing you have, okay? Now, you take the sunlight, okay? You take, let's say, a typical place in Russia, okay? You look at the spectrum over the year, right? And you calculate, with the sunny days or not sunny days and so on, you calculate how much available energy, like, subtract the visible part, you would, as a maximum, which you'll never reach, okay, you would have available, okay? Then you take the area of the window, okay, and account for the angle and so on, right? And you calculate the maximum amount of energy, if you could do perfect material, okay, you can actually get from that, right? And you calculate how much energy that is, and then, what you can do is that you calculate that as compared to the price of all other energy, right? As compared to the price of gas or oil, okay, right? This is just a very rough thing, okay? You don't have any technology yet, okay? And if you are, way different, right? Then you know that this is not maybe, like, the probability of that is relatively low, right? And then you can say, all right, this fundamental equation doesn't change, right? But suppose I put the real material in, then you can even say, before you do any experiments, right? Say, right, I mean, the best known material absorption, okay, in UV, but it's not transparent, unfortunately, is this. It's, I don't know, like 20% or something, whatever, right? Okay, and then you say, like, well, no, I don't really have those material choices. The best I could possibly think of would be 20%, okay? And then you put that into the equation, and you see what you end up with, okay? And this is what Gene was getting to, right? Is you get to this, a realistic, without having done anything, cost number, okay? And you compare that to other alternatives. And if you're there off by a factor of 10 or something, then it doesn't matter what technology you do, you'll never really get there. You see what I mean?
And so that process that we just talked about is sort of the way that you narrow remember when we talked about decreasing the uncertainty, right? That's how you do that, right?
But going back to the universe, you kind of need to do this for more or less everything, right? So you have this large technology universe of being able to cover a lot of things.
It was just one characteristic for discovering, which I said as example, because this covering will have some more characteristics and options like self-clearing and
but so you do this for all those.
You
right?
do it for all of
Same
that.
process
Okay,
for
so
all
it's
of
not.
Mhm.
So, but the point is, like this is what people in research do. Like fail to do, like sort of all the time. Is they like these simple back of the envelope calculations in the beginning, right? People spend years and millions on like research or nanotubes or whatever, instead of saying like, well, what's my surface area? What's the maximum? Like without doing any experiments. 1 page is enough. Okay. You make the calculation and then you kind of know. Like, but one of the reasons why people don't do this in research, okay, is because they don't want to know the answer. Because they might, because if the answer comes in negative, they say like, well, this is like I shouldn't be doing any research anymore, right? And it's my field of expertise, and it's very threatening to them, right? So, but in the innovation process, you have to, what we say is, okay, you have to be brutally intellectually honest, right? You have to work the numbers. It's not a matter of spinning a story, like how to get contract money and so on. It's a different story, right? It has nothing to do with the innovation process, right? You have to be brutally honest to see.
Yes, we know
what,
that our next step is accounting how much you save energy and then only go over.
Right.
Of course. But we have company who can calculate for us.
Oh, you can calculate it yourself. It's very easy.
No, they are specialists.
Well,
Okay.
this is what it would be good if you could do simple things on your own too. That's good because then that's part of the innovation process. You don't want to leave it as a black box to someone else. It doesn't have to be complicated. You can give yourself like a rough idea. It's good for you to kind of go through that and kind of understand. It helps you guide where you go to research yourself, right?
So you need to, I would even say strongly, you need to do it yourself, okay? Because unless you get a feeling for these parameters, okay, right? You don't. This is where innovation doesn't work, of saying like, oh, somebody's going to do technology and somebody's going to do marketing and somebody's going to do the calculation. That doesn't work, okay? Because there is no way you can get to a transparent decision-making process, right? Because you cannot say, like, give me a little example. If you don't do the calculation yourself, right? You just get back a number, okay? Then you don't know that in the middle of this page here, right? You say, oh, UV is 90% and infrared is 10%, okay? So no matter what I do, anything that has to do with infrared, I can forget about from the start. If I'm anywhere close, I better focus on UV, right? So if you don't know this middle part of the calculation, you'll never know that.
And what happens is you guys become the experts in that area because no one else is doing all those things, right? So what happens is you become the resource for that area, right? Because you are the ones that know how to really innovate in that, right? So anyway, we're gonna
Yeah,
go on to
but
the next.
but
We
then
have to go to the
you
next
have to
one.
look at like all the different
We need to go to the next one.
yeah.
Before we go to the next one, I think you should go back and reinforce
emphasize the whole restriction part in terms of the market, because you spend so much time on talking about the market
Yeah.
which is dead, which I'm like, why are you even doing that? If it's dead, it's... No, I mean, I don't.
No, it's good to know it's
Yeah.
dead. No, but that's valuable too.
But
It's
I
good
mean-
to know it's dead.
And it's
But
good to be
It's good-
convinced.
I mean, it's good to notice it's dead, but spend so much of your time trying to explain that it's a dead market
Right.
while you focus on something that might have some risk. So that's one thing.
Yeah, but
Let me try to explain our stages of research.
Yeah,
Yeah.
yeah,
I'm just-
that's good.
I'm just-
Yeah, she's just trying to show her innovation process. Yeah.
And going back to the needs.
Yeah. Oh yeah.
I
Yes.
think
Yes.
we
Yes.
get
Yes.
that one.
Okay.
Also
So let me emphasize. So the needs, okay, for the glass, right? So all the regulation and so on and so forth, all that is an implementation, okay? You have to separate, keep that very separate from the needs, okay? So whether it's for electronic application or for, you know, scratch resistant or high corrosion or, you know, resistant or whatever, okay? Those needs are the same globally. Right? So, and there are some very mature solutions, and maybe they're not all the ideal solutions, okay? But, so you have to like collect those needs, okay? And those needs, there are people behind it, okay? People behind it are, say, production systems that are run by people and so on and so forth. So it's a production facility manager who says, I'm going to use this glass for my plant or something like that, okay? So, but you can translate those, you have to understand those needs and you translate them down into product specifications, okay? And there are several mature, very mature sectors, okay?
It's really important.
Right? There are very mature sectors that have solved these problems with like, you know, hundreds of millions of dollars of investment, right? Like electronic glass, for example, okay? Right? It's the fusion process that Corning does, okay? It's you know, it's like you cannot get there with like sputtering or anything like that. It's the flatness of the surfaces of the glass, okay? It's a fusion process, but it's a very specific process, right? That, you know, you need to understand, and, you know, like it doesn't matter what you sputter, you're not going to get there, okay, unless you can do that, right? And because you have to get atomic flatness, you know, AFM sort of, you know, 2-3 atoms, you know, okay? So you know, so you need to like list those for all